Hello everyone, in this video we're going to talk about the different parts that are involved in a graph. Since this is algebra, you should already have graphed at some point. But in this video we're going to do more detail in labeling the little pieces. First I'm going to draw a graph. We have the y-axis, the x-axis. The x-axis is horizontal, the y-axis is vertical. We can make a scale with any number that makes sense for whatever our data is. If we had some numbers that are like 4, others that are around 20, then we would want to make a scale so that way we can fit these numbers in our graph. And you normally want to make the scale go just a little bit higher than the largest data that you have to plot. We call it plotting whenever you put points on a graph. You need to label the origin as 0. You don't have to put 0, 0, you just put 0 wherever the x and y axis intersect. Intersection is a keyword, and that means two lines cross. Since we labeled the intersections with an ordered pair, you could label the origin as 0, 0, but normally you just put 1, 0 because it's going to be in common. But if I had a dot at a specific point, then that point would need to be labeled with its x and its y. You always put the horizontal location first and then the vertical location. The horizontal for this green dot is not to the left and it's not to the right. So that means it's at 0 for x. Then the vertical is how high or how low is it. The height of this dot is 20. So the ordered pair is 0, 20 for this dot. Let me make another dot over here on the x-axis. And if I want to label that dot's location, then I need another scale. I need a scale for the x-axis. And you want to try to make your marks evenly spaced. This time I'll count by 3s. Your x and y scales do not have to be the same numbers. You can count one by 3s, the other one by 1s, or by 10s and 13s. You can count by whatever number you want, just as long as you keep it consistent for that axis. The location of that bottom dot is at, you remember you always put the x first, so you put the left and right. It is 15 to the right, so that's a positive number. And it is not up and it is not down. It is 0 up, 0 down. So the y is 0 for that one. I'm going to connect these two dots with a line. A straight connection between 2 points makes a line. If that line is bent, then you would call it a curve. We could make a curve between these 2 points, but we don't need to do that right now. But you do need to know that curves exist, and we'll talk about them later. This specific point right there has a special name because it's a dot where the line touches the x-axis. Where a line touches the x-axis is called an x-intercept. The location of this x-intercept is 0, 15. That ordered pair that I labeled earlier is the x-intercept. There's also a y-intercept. You get an x-intercept when you touch the x-axis and a y-intercept when you cross the y-axis. This ordered pair, 0, 20, is the y-intercept. And now that's everything that I can fit in this spot. So I'm going to copy this graph so I don't have to draw it again. You can have more than one line on a graph at a time. And if that happens, then they would call the two lines different names, normally a letter. Sometimes they'll give you the equation. The equation for line T needs the slope, which is the change in y divided by the change in x, times x, plus the y-intercept, which is 20. And that's something I'll teach you how to write the equation for a line in about a week and a half or 2 weeks. We'll be able to write an equation for a line. This second line, let's label something else first before I write the equation for that. I need to know something about that line. I said before that you need 2 points to make a line. The 2 points on this blue line, line V, are the origin and this one where the two lines intersect. If two lines intersect, then we call that a solution. There is a solution for these two lines' equations at the location. Let's mark the x for the ordered pair. It's after 6 but before 9. I'm going to put 7.5. And then the y is the height. So let's bring a dotted line to the left so that way we can see how high that dot is. That dot is less than halfway to 15, but it's past 10. So that location would be around like 11. Maybe 11 point something, but I can't tell unless I put more tick marks in there. That location is 7.5, 11. That's the solution. Now that I have 2 points for line V, I'm just going to make the slope equation, which is 11 divided by this times x. Now I have an equation for both of these lines. In this part, I just wanted you to know that lines have an equation that goes with them. The intersection of two lines is called a solution. And you can trace using a dotted line down and to the side to find the x and y for a graph. There are two branches of linear equations. One branch are the proportional ones. These ones go through the origin. They contain the point 0, 0, and the y-intercept of that equation is 0. That equation is going to look like y equals kx or y equals mx. For a non-proportional, that just means it doesn't go through the origin, which means it doesn't contain 0, 0, which also means that the y-intercept is going to be some random number. The general form of this is y equals mx plus b. That's a super important formula. Y equals kx is kind of important. As long as you remember y equals mx plus b, then you don't need to remember y equals kx because it's the same formula just without the b. And I'll put more details for those formulas once we get to those specific lessons. In case you didn't write down these two notes before when I wrote them on the graph, here they are again, the definition of the x-intercept and the definition of the y-intercept. The really important parts of these formulas to remember are, well, not even a formula. The important part of the x-intercept to remember is that the x-intercept happens whenever y is 0. That's going to be important when we're solving equations later. The y-intercept happens whenever x is equal to 0. When x is 0, that's the y-intercept. When y is 0, that's the x-intercept.